So welcome to this brown bag. We're going to be discussing find the shortest route kata, which I'm going to write in F#. This is from one of the katas that we've been doing within Trustbit for a while, and there's a link on the screen, but it'll also be in the video notes as well, I'm sure, hopefully. So the task at hand is to find the shortest route between two locations. For the purpose of this video, I'm going to do Cogberg to Leverstorm. So I have a nice little diagram here that shows all of them. I'm not sure if it's to scale or not, but we also have a CSV file that contains a start, a finish, and a distance. So before we start coding, what I'm going to do is have a look at the problem. So I'm going to talk you through how I would normally approach these sorts of things. So from Cogberg, I can go to Steamdrift, Rustport, Irondale, or Copperhold. So I'll do Copperhold to begin with. So if I travel from Cogberg to Copperhold, once I get to Copperhold, I know that I'm at Copperhold. I know that I came from Cogberg, and I know how far I traveled. And if I go to Leverstorm from there, I know once I'm at Leverstorm that I've reached my destination, but I know that I came from Copperhold and I know how far I've traveled there, which is fine for the moment. But also from Copperhold, I can go to Irondale, which again is okay. And I look at where I can go to from Irondale. I can go for Leverstorm, Gisborne, Rustport, and also I can go to Cogberg, but I've already been there. So what I want to do is I want to think how I'm going to store my data as I go through this process. So it might be better that when I get to Copperhold that I store where I've been and how far I've gone. And when I get to Irondale, I actually store the fact that I've been to Copperhold and to Cogberg. And I store the cumulative distance. And actually that should mean that the calculation I do at the end should be fairly trivial to get the shortest route out. If I find all of the possible routes, I can then just find the shortest and I'm done. There is one other slight problem with this as well, which is if I start from Cogberg and I go to Rustport and then go to Steamdrift, I then can't go anywhere else. So I'm tied to, I'm basically stopped, but that's not a destination. So I need to cover this case as well. What I actually did was draw out all of the possible routes. So this is what we're going to do in effect. We are going to start from Cogberg and exhaustively work out what all the routes are through this system. So let's get started. So all I have is a simple VS Code project. I've got Ionide, which is the F# compiler or extension method for VS Code. So I've created a simple project, a simple folder rather. I've got a folder inside called resources with the data.csv in there, and I've got a script file, an FSX file. They're not any different than an FS file, so the code that we write is basically exactly the same. So I said we're going to build a tree, or a hierarchical structure. So let's do that. So let's create a type called tree, and it's a generic type. We're going to build this is called a discriminated union. So the type can either be a branch of T and the hierarchical part, a tree of T, and that's going to be a sequence. Sequence is like IEnumerable in C#, or it can be a leaf of T. Now I need to think about T. So T is the thing that's going to store my data as I go through each of the nodes on this iteration. So I'm going to create a simple record type called waypoint. And that's going to have so I've got a location, which is a string. I've got a route, which is going to be a string list. and I've got a total distance, which is going to be an int. Okay, so they're the first bits that I need. So let's think about how I'm going to solve this problem. Well, I know that I'm going to be looking at Cogberg to Leverstorm. So let's put those in there. So what are my steps? Well, step one is I need to load the connection. So I need to load that CSV file and make it usable. I then need to get the possible routes. And then determine the shortest. And then display the result. So that's my task. So the first thing I need to do is load connections. So I'm going to use the .NET Core library, system.io. So I'm going to open that. Oops. And then I'm going to do path.combine. I've got a built-in, well, F# has a built-in value called source directory, which means I've got access to the files and the code within here. So resources and data.csv. And then I'm going to forward pipe that. I'll explain that a little bit later into file.read all lines. So what forward pipe does is it takes the line above and puts it into the end as the next parameter or last parameter within here. So I could have written file.read all lines and then the path at the end of it, but we're actually going to build a pipeline of data. So what I'm going to do is I'm going to make this a little bit bigger. I'm just going to run this bit of code in interactive. You can see there that I've got my data. So I've got a string array. I've also got a header row. So let's get rid of that. So I'm in array. So array.skip. I'm going to skip one row. And that's the only bit that's changed. I can just run that. So I've got rid of that row now. What I now need to do is I need to take the strings that I've got here, split them using the comma, and turn them into something else, into another type. So I'm going to create a type called connection. Again, it's going to be a record type. This is going to be a start, which is a string, finish, which is a string, and distance, which will be an int. Oops, this might. You'll notice that the compiler is telling me about the problems that I'm causing as it goes along. So I'm not having to compile, it's doing it for me in the background, which is really nice. So what I'm going to do is I'm going to pipe that into an anonymous function. So I'm just going to get access to the data from the row ahead. So rows could be anything, it's just a word, but that's the string array from above. And I'm going to create a list comprehension. So I'm going to yield some data from that array into a list. So for row in rows do, I'm going to do some pattern matching. So row.split based on the comma. And this bit we're doing now is actually in either C# 10 or C# 11, I can't remember which. So you've got a similar thing available now. So distance, what this is doing is saying if it looks like this, if it's an array, so split returns an array of strings, and it's got 3 bits in it, you can assign the values of those to these labels. And now I'm going to create the connections. I've got a red squiggle. So always look at red squiggles, telling me expected to have type int, but here it's string. So it doesn't do implicit casting. You have to explicitly cast. So that means that I'm in control of what goes on rather than the compiler thinking it knows what it's doing. So I need to handle the reverse cases. So the data that we have, data.csv, just contains one direction. I'm making the assumption that that it's the same distance going in the opposite direction. So I've got that, and I've got a red squiggle, which tells me I've got an incomplete pattern match. So anything that doesn't match that start of 3 items when it's split, I don't care about what the data is from that perspective. I'm just going to use the row that came in. So I'm just going to raise an exception. So fail with a little bit of string interpolation. Okay, so that's the only bit that's changed there. So let's run that. You see now I've now got a list of things, the square brackets time it's a list, and I've got Rustport to Irondale to Rustport, so it's done all the reverses. That's all good. So what I'm going to do now is a little bit of refactoring. I'm going to do, so I'm going to turn this into a function. It takes a path. I'm going to take that out and put it down here. Oops, I need to take that out, of course. Tab that in so it lines up. I'll create a function here called find shortest route. Tab those in. And I pipe that into connections. I'll highlight all of that again and run it. It should look exactly the same as it did before, which I hope it would. So that's done all my open connection stuff. So I've now got data. So now I need to think about where I go next. So the get possible routes. So this is where I start to create a tree. So get possible routes. And from here I need to start, a finish, and I need some connections. Actually, I've missed something out here, which I'll come back to in a second. Right. So this is okay. I've got a list of connections coming out here, which is fine, and I can do a filter on that. But when I use this, it might be easier if I convert this into a dictionary, so a key value pair, and convert it into that, so I can more efficiently find the connections. So I'll do that first. And use list.groupby. So this is a connection. I'm going to group by the connection start and end up with a tuple of strings, which is the start name, the start location name, and the connection list. So things that can go from things that are connected to that particular start point. And then I need to convert it to a dictionary, and we're going to use map, which is a read-only dictionary. So of list. And that's it. So I can run all that. And hopefully you can see there I've got a dictionary now, so I've got a key and values. So the EXN is just to say raise an exception. All I was trying to do is get it to compile. So I now need to create a recursive function that's going to generate my tree. So we do that by using the rec keyword. I'm just going to call this loop for the moment. And my data is a waypoint. So I'm just going to call it a waypoint for the moment. In fact, I don't like loop. So I'm going to call it process waypoint, so I know what it's doing. So what do I need to do in here? Well, I need to find all the routes that I haven't been to so far. So I need to find unvisited routes, and then I need to handle the leaf case and the branch case. So when do I do both? I also need to start my call out to the recursive function. So I'm just going to call that by process waypoint, and my initial waypoint is going to have a location of start, route is an empty list because I haven't been anywhere yet, and total distance is 0, so I haven't traveled anywhere yet. Okay, it's just telling me that I haven't filled in the code. Right, so let's have a think about unvisited then. So what is that? So we've got a dictionary. So I need to find I need to find my start point, get all the connections for that. I need to filter out all of the connections that I've already been to. So list.filter. And this is a connection. And now I need the routes from the waypoint. Route. Unfortunately, there isn't a not exists. So what I have to use instead is exists, and I have to do a negative on the end of it. So this is a list of strings or locations. Equals, so connection.finish. So have I already been to the finish? And then I want to negate it, so I'll pipe it into not. And now I need to convert the connections to waypoints and do the accumulation at the same time. So I'm going to do a list.map. So this is a connection. I'm going to convert a connection to a waypoint. So a waypoint has a location. So location is the connection finish. The route is the connection start, which I'm going to append to the front of the list using the cons operator. So waypoint.route. And then total distance is the waypoint.total distance plus the connection.distance. Okay, that's looking reasonably good. So now I've got the leaf case. So when we looked at the diagram earlier on, we talked about it'll be a leaf when it finishes, when it reaches the destination, or if you can't go anywhere else and you haven't reached the destination. So let's cover that case. So waypoint.location equals finish, or unvisited equals an empty list. I'm just going to return a leaf with the waypoint. Else I've got a branch, and the branch consists of the waypoint and then a sequence of tree. So I'm going to use a sequence comprehension, just like I used a list comprehension earlier. So I'm going to, oops. So I'm going to loop through this unvisited list. So for next in unvisited, do process waypoint next. Oops, in a space. I've got a blue squiggle. What's that telling me? Add a type annotation. So connections is a map of string and connection list. So most of the time you don't need type annotations, but sometimes the compiler says, I don't really understand what you're doing, so make it obvious. So string connection list. That should be it. Okay, so get rid of those. So that's good so far. What I need now to do is to, I've now got a tree. It doesn't tell me, but I have got a tree somewhere. Yeah, so process waypoint will produce a tree of waypoint, but actually I'm only interested in the leaves. I'm not interested in the I'm not interested in anything else. So let's go and extract those. So get leaves, pass the tree in. We match the tree, so there's pattern matching again. So it's either a leaf of, and it's a waypoint. And I'm going to wrap this up in a list because we're going to combine them together. So building things together is easier with a collection of things. And we're going to use a function called collect. So we end up with a list with lots of nested lists inside it, and we can basically extract all the waypoints that we're interested in and throw away all the other lists apart from the outside one. So we just end up with a list of waypoints. So branch. So branch is the initial waypoint, which we don't actually care about, and the rest of it. But the rest of it is this list of branches and things is a sequence, but I want a list. So I'm going to convert my sequence to a list, and then I'm going to do list.collect and then get leaves. It's telling me it doesn't know anything about it because I haven't marked it as recursive. So you can only call yourself if you've got a recursive function. So let's get leaves. So I'm going to pipe that into there. Which is fine. So I've got all the leaves, but I've got leaves with not the correct destination on it. So I have things that potentially have things that don't, that I'm not interested in. So I'm going to filter those out. And this is I've got a list of waypoints. And I just need to check that the location is the same as the finish. So let's plug this in. Get possible routes. So I don't have a start and finish yet, so let's pass those in. Let's call this down here. Space. Okay, so let's unroll this and run it. Just make sure it works. So it's in interactive. So I've got some data, and these should all finish at Leverstorm and tell me the total distance. I can order them and all sorts of other things. So finding the shortest route now is actually trivial, because I can do a list dot min by total distance. That tells me that's the shortest route. And let's just make it a little bit more. It's also in reverse order, so I'll sort that out as well whilst I'm at it. So I've got WP dot location. Use the cons operator as well again. So W dot route. I can then pipe that into list dot reverse. And the other one is WP dot total distance. Voila, all done. So 60 something lines of code to solve that problem. I think that's quite efficient. So it's obviously not the most efficient route. So I wrote another one as well, which is available in the code, which does it in a slightly different way. But even this is relatively fast. So if you're interested in this sort of stuff, and you should be, I've written a book, which is available on LeanPub. It's free. And at the moment it's out in beta. It's nearly done, and it'll be finished on the 17th of July. Thank you for listening.